Hello everyone, welcome back to Adding with the Code 2020. We're going to be doing day 22 today in Haskell, as always. Let's get started. Day 22, Crab Combat. It only takes a few hours of sailing the ocean on a raft for boredom to sink in. Fortunately, you brought a small deck of space cards. Why is this just a link? Oh, link to 2019 day 22? I didn't do that one, so... Alright, anyway, it's just a bunch of numbers. You'd like to play a game of combat, and there's even an opponent available, a small crab that climbed aboard your raft before you left. Fortunately, it doesn't take long to teach the crab the rules. Before the game starts, split the cards so each player has their own deck. That's our input. Then, the game consists of a series of rounds. Both players draw their top card, and the player with the higher valued card wins the round. The winner keeps both cards, placing them on the bottom of their own deck so that the winner's card is above the other card. If this causes a player to have all of the cards, they win and the game ends. So it's called Combat, and it's exactly like the game War, at least, I don't know. Maybe there are regional variants or whatever, but at least where I grew up in America, there's a game named War that plays exactly in the following way. I guess War is actually more complicated because there are ties, right? There's like 2 kings in the deck. Well, 4, right? But in particular, it's possible for 2 kings to both be drawn. And then you have a combat resolution for ties. But War is this combat game is even simpler. The main difference is that it prescribes how the winner adds cards to their deck, rather than just being just like arbitrary, which is good enough for War. And blah blah blah. So once the game ends, you can calculate the winning player's score. The bottom card in their deck is worth the value of the card multiplied by 1. The second from the bottom is worth the value of the card multiplied by 2, and so on. With 10 cards, the top card is worth the value on the card multiplied by 10. Cool. So this seems like super simple. All we need is like a double-ended queue, right? And we have that. That's one of the things data sequence is good at doing. So we will use data sequence today. I guess we should probably start by defining some types. Here's our input, by the way. It's not even a very large deck. Looks like it goes up to about 50 or so. So each player probably has around 25 cards. Let's go to 52. No. Yeah, 50 is... Okay, everyone has 25 cards. Fine. I guess maybe part 2 will tell me, oh, I forgot, there's a joker, and I don't know. That's how the 52 card deck is made up. So we can parse this pretty simply. We might as well do the parsing first. And I don't think we even need text regex applicative for this. Let's define, I don't know, data, new type deck is just a deck of list of card. Type card is int. Oh, we don't want a list, do we? We want a seek of card. Import data seek. Data sequence? Okay, the type is called seek, but the file is called sequence. Okay. So prepare is honestly, like, let's just make this a type alias now, for now. And if we need to make it a new type, we can. Our input is going to be 2 decks. Wasn't there like Haskell data list? There's split on or something? Or is it in the prelude? Oh, it's in data list split, right? Data list split. Split on. Yeah. So we want to call lines, then we want to split on. Let me go get my Cabal file and add split. Split on empty, right? Because we know composed with lines. Map parse, let's say. And then we will say deal, I don't know, where deal of AB is AB, and parse of player name cards is map read cards, s dot from list of this. My GHCI process seems to have died. All right, Emacs, you're dead. Anytime the GHCI process dies, it's just like impossible to get back, but restarting Emacs always works, so at least so far. So we called lines. Split on an empty list. There should be a single empty line, and I want to split on that. So deal is a function from list of deck, I guess, to input. That's fine. Parse is a function from list of string to input deck. Okay, this is what was wrong all along. I thought maybe it had inferred some bogus types, but no. We called lines. Oh. No, hang on. When we called split on, what is the type of split on? It takes, oh, a single list of string? Oh. That's weird. Huh. Why does it need that? Well, whatever. Seems fine. And I guess we need then a function one round takes a pair of decks and produces a pair of decks. Oh, and I have to import a bunch of stuff from data sequence to actually work with it. I don't remember what's, or I don't have to import, I have to know what it is. Haskell data sequence. I think mostly what I just need is these constructors. Yeah. Right, I remember now. It's just and the this is the deconstructor, and the constructor is just the same thing without the colon. Okay. So one round. Oh, you have to import. No, I'll just not import that stuff. Right. Of top and which in our input is the top of their deck what's given first? I assume so. Puzzle input. So 9 is the first element. Yeah, okay. And that's how we will structure it. Okay. Top of the P1, C1 over P1 and C2, P2. Just confirm that that works. Oh, S dot. There you go. I don't know. I could import those. They're kind of gross with the S in front of them. That's fine. And I also will want add to the right, which is that. That's how you import constructors? Okay. It's kind of a mess of parentheses, but all right. That's what happens when you have an infix constructor, I guess. The imports look a little weird. Now, simple enough. We say if C1 is greater than C2, then it's P1. Hang on. What order? Okay, they take the sequence where the pipe is. Got it. So we're writing it like this. We want the winner's card first, so that's C1, C2. And then return P2 unchanged. And we'll go ahead and we'll write a non-exhaustive pattern here, and we'll like throw an error if it's if they're equal. Is P1 and then P2, adding C2 first and then adding C1 under it. Wait a minute. Am I adding these in the wrong order somehow? I don't think so. The winner keeps both cards, placing them on the bottom of their own deck so that the winner's card is above the other card. Yeah, this is right. Okay, so you're warning me on one round is unused or what? No. Oh yeah, one of them could be empty, sure. But I won't let that happen. So part one I think is pretty simple. We have decks. We want to iterate one round, obviously, and just like trying to, I don't know, let stages equal iterate one round decks. Fine. Finished of empty this equals true finished of. Is empty what the constructor is called, by the way? I already forgot. It's not. Empty, of course. Capital E. You can only pattern match on capital on constructors. This is a fake constructor, but good enough. Final is the first. Oh, actually, you know what? It would be kind of nice to return the deck that's finished, wouldn't it? Yeah, maybe what I'll do is say winner is my new function. And it returns maybe a deck. Just P2. Just P1. Nothing. And then instead of iterate, I can use unfold R. I think. Where is unfold R? Unfold R. It's in data list. So we won't do this. We'll let stages equal unfold R So unfold R has to return a value to emit and also a seed to continue. And the seed to continue is the new dex. Or it returns nothing if it's finished. Unfold R doesn't seem like the right function for this. Because once we've determined we're done, we don't want to like continue, but we do want to yield a value. All right. Over dex. Final is winner of I am mapping winner over. No, I have a list and I want to map winner over it to figure out when I'm done. Yeah, so I guess I want list to maybe, no. Head of cat maybes map winner over stages. just make this text really, yeah, okay, so this all type checks, which is lovely. Oh yeah, it's all, I always forget map maybe. Thanks for reminding me. And so score of an empty deck is 0. Score of C. No, hang on. I just want to do this as a fold, don't I? We could zip with a list of integers, which is the multiplier for each of them. It's a little bit annoying. I thought there'd be a cute way to, like, just take the score you already have. Like, the first card should be scored once, and then the next card should be scored twice, and so on, assuming you're starting from the bottom. And so that's kind of like taking the score, you know, taking your starting score as 0, adding the first card to it. Then take that score and add the first and the second card. Then take that and add the first and the second and the third card. But that's not the same as adding your running score total, sadly. So I assume like we have seek has reverse or something. Yeah, reverse. Gives you the sequence in reverse. It costs order n time? Can you like traverse it in backwards order or something? Transformations? Folds, maybe? Is it a fold? General folds are available if you have a foldable index of seek. Fine. But I kind of thought, since you have fast access to any index, I thought you would be able to like implement a reverse view of a seek. Oh, is that view L and view R? To view it as a list? I think that's what I'm looking for, right? Just search for view. View R. I see. So you call view R, and it gives you back a view R, which is like a list, but not actually. But it is foldable. So we can fold over view R. Actually, we can map a cum L over it, I think. No. That would be giving me back a list of results, which I don't want. I want to fold. No. I just want to zip it with the integers from 0 to n. Yeah. Okay. So score is not taking. Okay. So we score of a deck is some zip with times, I guess. Zip with times and integers starting with 1. S view R? Something's not right. Oh, lowercase r. Oh, map maybe returned... what's wrong here? Oh, I said I was returning unit. I guess I don't want zip width. Zip width only takes lists. So I guess I want toList from foldable. There we go. We'll probably want winner to be a top level function, but for now this looks fine. Error. Nobody won. That's interesting. I don't think that's possible. So what was the input that you thought nobody won? Three equals 8. Well, I don't agree with that. Oh, I swapped. Okay, I swapped both the order and the cards. Okay, 3 equals 8. There you go. That's fancy math for you. Okay, 32,753. Let's just see if that's right. Too high, too high. Okay. Putting the winner's card above the other card. That's what I've done. All right, well, let's run it on the test and see what we get. I assume it'll be wrong, but it should be pretty easy for us to inspect the intermediate state as well. Oh, I need to... Wait, what? I thought I wrote example here. What am I crazy? I don't know. $299. Oh, interesting. We're off by 1? No, the score we're expecting is 306. All right. Well, one thing we can do is we can get rid of this now. It's non-exhaustive anyway, and we solved that problem. Is to say part 1 of decks, instead of scoring the final deck, just show me the final deck. Are we scoring wrong, or did we run the game wrong? So we're supposed to have, I'll read you the puzzle input. 3, 2, 10, 6, 8, 5, 9, 4, 7, 1. And that's exactly what we have. So we ran the game correctly. We just scored it wrong. That's interesting. What do you get when you view R this? It should be like 1, 7, 4, 9, etc., right? No, it's still in the same order. Am I supposed to view L? I've been imagining sequences backwards in my head the whole time? What? If I put a view L here, what do I get? Huh. Okay, so I would have thought that the view sequences would be foldable in the direction that you're analyzing them from, but apparently not. They both just give you the data in the same order as the original sequence. What? I could call reverse. I know I could call reverse. It's not hard, but like that's not. When you're given like this powerful data structure with a bunch of cool functions in it, and it seems like it has a bunch of stuff that is supposed to be performing well, and then you find some operation that's like, oh, just do it the inefficient way. It's like, what? There's got to be something I'm missing here. So suppose that I said Haskell data sequence reverse fast. What if I search for that? Reverse fold? Data sequence foldable and traversable. How, like, why am I not finding this anywhere? Is it just like not actually possible to do quickly? I find that shocking. I guess, okay, maybe it actually is impossible to do efficiently. I've imagined sets as like having constant time access to each element. It's logarithmic probably, but either way, I guess if you can reverse in order n, that's like the fastest you could possibly do it, right? You're doing, the result that you get back is a list, and it takes a very small amount of time to look at each item in the resulting list. Actually, you know what? I just realized I don't even... I imagined s.reverse would be free. I imagined, I guess, that it would be cheaper if I don't need the structure of an entire sequence back, if I just needed a list back. I still think that should be true, but apparently not. S.reverse. So I assume if I do this, it comes out in the right order, yeah? Hang on, did I actually save? I did. Yeah, okay. Score final. $306. So that's the right answer for the example input. And now on my real input, it'll be larger, presumably, than that. It's guaranteed to be larger. Yeah, but we were off by like 3,000 last time, so. Okay. That's the right answer. Cool. We didn't end up using lambda case. Let's put the type signature back in. Day 22, part 1. Okay, on to part 2. You lost the small crab. Fortunately, crabs aren't very good at recursion. To defend your honor as a raft captain, you challenge the small crab to a game of recursive combat. Recursive combat still splits them into 2 decks. You offer to play with the same starting decks as before, it's only fair. Then the game consists of a series of rounds with a few changes. Before either player deals a card... Oh dear. If there was a previous round in the game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. This prevents infinite games of recursive combat, yes. Otherwise, this round's cards must be in a new configuration. The players begin the round by each drawing the top card of their deck as normal. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat, see below. Otherwise, at least one player must not have enough cards left in their deck to recurse. Yes. The winner of the round is the player with the higher value card. As in regular combat, the winner of the round, even if they won the round by winning a subgame, takes the 2 cards dealt at the beginning of the round and places them on the bottom of their own deck. Note that the winner's card might be the lower value of the 2 cards. Yeah, sure. If collecting cards by winning them causes a player to have all the cards, they win and the game ends. Okay, so what I'm trying to understand is, like, when you take cards out of a deck, when you play a subgame, what happens to the cards that are involved in that subgame? Even if they won the round by winning a subgame. Like, if I play a subgame with you, must be in a new configuration. Game ends. Like, we're entering a subgame, right? Call that game B. And we're in the middle of game A, where we've each drawn a card and we each have a deck of a remainder, like a subdeck, right? A new game of recursive combat. Ugh. So let's walk through the example. If both players have at least as many as the card they just dealt, you recurse into a subgame, yes. Player 1 draws 3. Player 2 draws 7. Yeah, okay, not counting those. Sure. To play a sub game. Okay, here's how they explain how to play sub games. We hadn't gotten there yet. That's why I didn't understand it. Each player creates a new deck by making a copy of the next cards. Good. Okay, so we don't have to worry about that. Equal to the number on the card they drew. During the subgame, the game that triggered it is on hold and unaffected. No cards are removed from decks to form... Okay, that's much better. And when you win the subgame... you just get one card from them. And that resolves that subgame. Okay. I think we do a similar thing. We just make one round recursive. And we'll define a function. We'll extract out most of part one. Or like run, I guess, is a function from pair of... it's a little more complicated because we have to decide who's winning as well, right? What I really need is a function that takes a pair of decks and produces either, well, it produces like a winner of that round, right? And we would reuse that in one round. Let's try writing one round recursive and see like how it turns out before I figure out how to factor stuff out of part one. Maybe it won't be natural to reuse some of the stuff that was here. Recursive round is a function from pair of deck. Oops. To another pair of deck, I think, right? Okay, so problem with this is that previously we wrote one round assuming we would never like run out of... we would never run into the exhaustion criteria of a deck being empty. But I guess this is fine. Let me double check. What's this deal about repeating conditions? Because actually that's sort of an issue. If the game instantly ends in a win, previous rounds from other games are not considered. I can't quite tell what this means. When they say the game, do they mean the sub game that we're in or the top level game? Let's see if there's an example. There's a game 1 and a game 2. It's hard to tell. What is the winning player's score? From the cards they have in their original deck? What does that mean? Surely it doesn't mean the deck they started with, because then you could just, like, look at count player 1's deck, and then count player 2's deck, and try both answers, and one of them would be right. So I think they mean, like, by original deck they mean not one of the copied decks, I guess. But the original deck has changed, but it's still the original deck. The order of cards, ugh. I don't like this wording. Like, my question basically is this rule set here, like, important? From other games. Or is it just here to, like, help you realize that the game is not going to go on forever? And if it does come up, I don't understand how to interpret it. It's not the winner of the round, it's the winner of the game. If there's a previous round in this game, okay. Previous rounds from other games are not considered. So I think we can reasonably suppose this will come up. And we end only the subgame and declare a winner from it. Okay. So we'll need a set, I suppose. And I probably want state? Yeah. All right. Let's stack build, I don't know. Let's write a function called winner. You know, I feel like I should have some useful alias for this deck thing, but I actually, like, I shouldn't call it a game because that's not what it is. P1 wins. Bool. So we can do a few things. We can say P1 wins of S empty is, I don't know, like what happens if it says they draw a card. It does not consider the possibility that player 1 or player 2's deck might be empty before drawing a card. So I guess I can just like, I'll assume that won't happen, but I'll implement it anyway, why not? I mean, like, if your deck was empty, and you were supposed to draw a card, like, yeah, I guess in some sense you didn't have enough cards to recurse. Now, otherwise, do I need, like, state here the whole time, or just when I start recursing? I guess I need... I need a function like run game or something that runs an entire game. Yeah, maybe P1 wins is the wrong type signature. Run game is a function from deck and deck to state of set of pair of deck and bool, which is whether player 1 wins or player 2 wins, right? I guess I could still call it P1 wins. Okay, import. I have seek and set, huh? And we need import control monad trans state strict. I already put it in. Alright, it's like, alright, get out of here, Emacs. You are no longer smart enough to run this program. Okay. So we'll need more functions from state, but I'll just add them to the import list when I want them. So what are some other end conditions? P1 wins of G as P1, P2 when I actually can't easily write this as a guard because the set of previous states is in the state. It's not in my actual parameter list, huh? Okay. If no, I need to say retrieve from get, I suppose. Do I need run state? No, I just need eval state, right? Get, modify, I guess, are the things I need. Actually, I don't think I need get if I have gets. Loop, let's say, is gets s dot member g, not s but set. If loop, then pure true, with a loop so player 1 wins, else do modify of s insert g, set insert yeah, and it's just saying the types. I haven't. I wish I want to indent it like that, but Haskell Emacs doesn't want to indent it that way. Whatever. I won't fight you, I guess. So that's one case. Loop. Okay, we've basically done everything we need to do in state, I guess. Well, no, we have to do. We may have to play a subgame in state. I'll. But the subgame shouldn't consider this game's previous state. We only need. Okay. Let's just let some things and figure it out later. C1. I did import these, right? Yeah. P1. I can do this. Now I don't need to let these things. Okay, we drew the round. If they both have at least as many cards remaining, you play recursively. So I want like conned, right? Which I understand there's like multi-way if. I mean, we might as well turn it on, right? What? Language multi-way if C1 is less than seek length of P1, or greater than, I guess, is false. You definitely lost. Oh, hang on. No, you don't lose if you can't recurse. If either player can't recurse, the winner is just. No, I don't even need multi-way after all. Let's let P1 prime be seek.take of C1 on P1. P2 prime equals seek.take C2 of P2. So both players have now nominated the decks they would like to compete with, and we can just check if they're both the right size. If seek length P1 prime equal C1 and seek length P2 equals C2, then so they both got a deck as large as they needed. Then we should eval state, start a new subgame of P. What order does the eval state take its arguments in? Takes the initial value first. S dot set empty of P1 wins of P1 prime P2 prime. Else, one player could not create enough of a deck for a recursive subgame, and so we just determine the winner, which is C1 greater than C2. Parse error. Well, okay, if there's a parse error somewhere, that would explain why this is indenting all weird. Where would you say my parse error is? About line 41, huh? Is it really this? No. My imports are okay? They look okay. You're killing me here, Haskell. Just like, there's a parse error somewhere, nobody knows. Oh, hang on, this is indented wrong. That does make sense. What's wrong here? Eval state set empty. Oh, it takes in the other order. I read the docs wrong. Oh, hang on. Takes a state. This. The state of bool. This looks right. What's going on? Couldn't match expected type state set a bool with bool. Oh. Yeah, this is a little bit weird, but we actually have to, we do not want to share state. Oh, actually, is there some weird, like, some weird way to, like, run state? There, you can, like, you can modify the state of subcomputation. I don't even know. Yeah, that seems like a bad idea. Yeah, we just want to. It feels weird to like create a stateful computation and then run eval state on it inside of another stateful computation, but it's important. We want to make sure these do not share any substate. So I think this is like we're pretty much good here. Well, not really. um, is it okay? I don't think so, because we haven't. If I just if I just use this P1 wins at the top level, it's like won't work, I think. Because there's no the recursion in it doesn't involve moving around decks. And we would only move stuff at the top level, like yeah, something's not right here. I need P1 wins to be more closely tied together with my next round function, I think. So that it when it takes when it gets to this step, it can actually take a card out of somebody's deck, or in either of these cases, right? So maybe structuring this whole thing as P1 wins was the wrong idea. Well, I don't know. Yeah, it kind of is. No, I mean, I think here's my problem. Yes, this is what's wrong with P1 wins. It doesn't tell you who wins a subgame. It tells you who wins the first round of that subgame that is resolved by comparing cards to each other. I think. Well, no, because that is the winner of the subgame, right? Obviously, what's wrong is that we never move cards around, but I'm trying to figure out where I'm supposed to put that. So say I'm at the top level, I can call P1 wins, and then I can move the decks around and call P1 wins again, right? Maybe this is fine? So P1 wins. I see, I think. The problem is that I'm confusing P1 wins a round with P1 wins the game. Right? I have here, if there's a loop, P1 wins the game. But here, I'm determining who wins a round. That's the problem. I need to actually, like, it's great. I can figure out who wins the round. But I need a way to win a game. And so I think I need P1 wins game to be the main thing. And winning the round is pretty simple. So what we do here is we need to run this computation to see who wins the current. We're starting a subgame and we need to see who wins it. Okay. So let's let round winner equal. Okay, fine. Equal if. It's kind of gross, but then this, else this. Oops. Now I've figured out who won the round. And I can say if round winner, then P1 wins game of like this, else P1 wins game of this. Oh, yeah, that's a good point. This is not a pure computation. It's a stateful one. Okay, so what's the warning here? Ah, now I don't need pure anymore because this is... Okay. Now it's not embedded in state because I moved it up into this let. Okay. Okay. Then what is it that I need? I guess what I need to do is change one round. Well, hang on. P1 wins game. Is that really what I need? I need to know who wins a round in order to advance. in order to actually advance, right? Right, I need a deck as well. I mean, it seems a little bit wacky, but I could have this return either a deck or a deck. I.e., like, if player 1 wins, return their deck. If player 2 wins, return their deck. Or I could return a Boolean and a deck, which is the same thing. Yeah, I should return the winner's deck, right? That makes sense. Bool deck, let's say. I guess it probably doesn't matter. Like, when do I need the winner's deck? Only at the very end, right? So all these other sub-computations are just going to ignore the result. It's a little tricky because P1 no longer contains C1 when I do this, right? I guess we don't need the deck here, right? Is that really all it took to plumb through all the changing decks? I mean, I guess I still have to do this. I'm kind of really not excited about this. This doesn't seem right. One player must not have enough cards left. The winner of the round is the player with the higher valued card. The winner of the round. So I'm saying if once we've okay, one termination condition is someone couldn't draw a single card. I don't think this will ever come up, but just in case, here we're saying we could each draw a single card. If we've seen the state before, then player 1 wins and return his deck. Now give everybody new decks and determine a winner of this round by running the whole game, ignoring the resulting deck because we don't care about it. Yeah, this actually seems okay. Let's just write part 2 by hand and then figure out how we're supposed to share it with part 1. Actually, I don't think there's much to share because P1 wins game does all the deck fiddling for us. Oh, I don't know. I guess there's stages, final, score, or final and score anyway. Int part 2 of dex equals let winner equal P1 wins game eval state set empty, but it takes its arguments in the other order. Oh my god. Okay, now I have the winner. In sum.zip. Let's just yeah, we can define a function easily enough called score deck, takes a deck and int. We'll just call it score, in fact. Score equals this. In score winner. I mean, I don't know. I guess we can try running it. This is not exactly pretty. I kind of want, yeah, whatever. Oh, I just said build, run. I don't know why I was just building to make sure I got dependencies or something. Okay, I mean, it's a number in the same ballpark as the last one, but not identical, so that's promising. That's the right answer. Okay, great. See, recursion's no problem. You just write a giant, like, I don't know, 16-line function, and it's just right the first time. Like, what's the problem? I don't know. I think in a lot of languages, you would consider a 20-line function like pretty reasonable. But Haskell is very dense. You can do a lot with a small function, and I think this function is like almost large enough that you really ought to split it up somehow. But I think it's kind of a nice representation of the rules of the game, like kind of all in one place, and there's not an easy way to split it up, I think. So I don't know. I'm reasonably happy with this, I think. Let's move one round into part 1, though. Since we didn't end up using it for part 2. What are you upset about? Pattern match has inaccessible right side. What the hell does that mean? Inaccessible right side? Overlapping patterns. Pattern match has inaccessible right side. I don't care about type rep. Here's a here's a GHC bug. This warning is confusing for users. That's the top hit. Pattern match checker makes the distinction between redundant matches and matches with an inaccessible right-hand side. A pattern with an inaccessible right-hand side is a redundant pattern which forces the argument, so affects strictness. I don't think I have any redundant patterns. Okay, so basically the bug is just saying that from a user's point of view, an inaccessible right-hand side is the same as redundant. But GHC tells the difference, considers them different, because if it's redundant but affects strictness, it's not redundant. It's just inaccessible. But I don't have any overlapping patterns. What? I still don't understand this at all. Like, if I said otherwise equal mempty or something, it's still inaccessible. No, now it's just non-exhaustive, which I totally agree with. I left it inexhaustive on purpose. I disagree. I don't think there's an inaccessible right-hand side. It's very weird. All right. You know, I guess we might as well get rid of D2. It is in fact unused, and adding it for symmetry doesn't matter that much. Okay. Day 22, part 2. Ooh, all right, we're almost to the end. I did skip, day 20, part 2 or whatever, but that's fine. We should be only 3, 4, 5, 4 more days left. No, 3 more days left. I should at least do a video for each of them, even if there's one I decide not to implement because it sounds like a grind. We'll have at least a video. So anyway, hope you guys have enjoyed. Thanks for watching, and I'll see you next time.